Hello, Rickoff here. Welcome to video number 33 of Rick's Pipe Dream Magnetic Motor Generator Project series. What you are looking at is a view of my computer monitor, and I am reviewing at this time the test that was shown in the last 30 seconds of my previous video. I came to the conclusion that it would be very nice to determine the actual elapsed time of the movement between the first plate and the last plate of the series. And to do that, I would need some kind of a timing device. And here's what I came up with. I searched high and low on the internet to see if I could find a suitable timer for timing these tests. And there were very few timers available that would do the things that I wanted. What I basically wanted was a timer that would show seconds and hundredths of seconds. And I wanted something that I could see easily and something that I could utilize for a wide array of different tests. Now, I did find a couple of physical devices, and it seemed that they started in the neighborhood of about $50, and some were more expensive than that, and they were about the size of a handheld calculator, and you could set it up on your test bench and run some wires to a switch where you could click the switch and start the timer, or else you could press one of the buttons on the timer to start and stop the timer that way. I then thought about the possibility of either building a device or developing a software timer that I could use and which would have the capabilities that I wanted. However, that seemed like it would take up a considerable amount of time, and it would of course take me away from my experimenting. So I decided to do another internet search, and this time look for a software timer. I thought surely someone out there must have built a good software timer. Here it is. Now, this is called X-Note stopwatch, and you can go to their website and learn more about it there. And the website is xnotestopwatch.com. That would be xnotestopwatch.com. Now, this is a wonderful timer, and it has many different functions, and many of those functions I will be utilizing in my experiments. Now, as shown here, you'll see that you have hours, minutes, seconds, and then hundredths of a second. Okay? Now, I won't be needing the hours or the minutes. What I'm interested in at this time is seconds and hundredths of seconds. So I go into the menu here, and I go up to time format, and then I can choose. Let me bring that down a little bit. I can choose to take off the hours and the minutes and just leave seconds and the decimal part, the hundredths of a second. I click OK. Okay, now that brought me down to a nice little size. And this is exactly what I need, seconds and hundredths of seconds. I see the numbers are very easy to read, and I've chosen a background color of a bright yellow because that contrasts really nice with the black digits. However, you can select any color you want basically, and you can select any color for the background, any color for the digits. Now the way this works, you have a button over here on the left. This is a start and stop button. Right now it says start. If I press that, the timer starts. See, and then it turns to stop on the button. So I press it again, it stops. Start, stop. Okay. Now to set it back to 0, there's a reset button. Okay, so this is what I'm going to do. I'm going to start the test at the position that's shown right now with the back end of the stator lined up with the leading edge of the metal plate sections. See that? Then I'm going to stop the timer when travel gets to the full extent. And this would be the point where the rotor does not turn any further. It will actually come to a stop just before reversing rotation, right near the end of the metal plates. Now I'm going to back up the stator just a little bit to about the same position where I started it in the last test. Okay, I'm at the starting position. And here goes. I'm going to start the motion now, and then I'll start the timer when the stator's lined up over the plate, the first plate. Start. Stop. Okay, we have 7.49. 7 seconds and 49 100ths. Now I've wound the rotor back to the starting position again, and I'm going to go through the test once more and time it again. Now this time we see the reading that we had on the last run, and I'm going to start another instance of the stopwatch. See, we're zeroed out, ready to go. And that way we can compare our readings between the two tests. I want to see how close I am at approximating. The test should be the same. However, you know, there's going to be some kind of a difference here because of my finger on the mouse. When I click the start and end positions, it's going to vary from test to test, right? So let's just see how much it does vary. It probably won't vary in the seconds range, but when you get down to the nitty-gritty of the hundredths of a second, there could be quite a difference. So let's just see what kind of a difference we get. Start. Stop. Okay, you can see that I was fairly consistent. I'm off about 9 100ths of a second. Now, 9 100ths of a second, or that's less than 1/10 of a second. So, looks like I'm fairly consistent there, but there is another factor going on here. It's human error, of course, and that gets to the situation where maybe I clicked the mouse at a different time when I started, or I clicked it at a different time when I stopped, so that's a possible double error there. And this is definitely going to affect the timing results.